Have you ever pondered over what lies beneath your feet, deep within the Earth? Peel back the surface of our planet, and you'll discover it's not just a solid lump of rock. Rather, it's composed of several layers, each with its own unique characteristics and roles. Much like peeling an onion, or in this case, cracking open an egg. Let's start with the outermost layer, the crust. This is the part we live on, the surface beneath our feet. It's like the eggshell, thin and brittle. The crust ranges from about 3 miles thick in the oceanic regions to about 45 miles thick in the mountainous regions. Beneath the crust, we encounter the mantle. Much like the egg white in our analogy, the mantle is the largest layer of the Earth, making up about 84% of the Earth's volume. It's composed of silicate rocks rich in iron and magnesium, and it's incredibly hot, with temperatures reaching up to several thousand degrees Celsius. Deeper still, we come to the outer core. This is Earth's only liquid layer, a sea of mostly iron and nickel that's so hot, the metals are in a molten state. Imagine it like the yolk of our egg, swirling around in the center. Finally, at the heart of our Earth lies the inner core. Just like the germinal disk in an egg, the inner core is small but mighty. It's a dense ball of solid iron and nickel, about the size of the moon. Despite the intense heat, hotter than the surface of the sun, the immense pressure keeps it in a solid state. Each of these layers plays a crucial role in making Earth the vibrant, life-sustaining planet that we call home. They're responsible for everything from the magnetic field that protects us from solar radiation to the tectonic activity that shapes our landscapes. So, just like an egg, our Earth also has different layers, each with its own unique properties and roles. Scene script. Have you ever wondered why the ground beneath us trembles during an earthquake? It's a fascinating yet terrifying phenomenon that has fascinated scientists and lay people alike for centuries. To understand earthquakes, we first need to delve deep into the heart of our planet and explore the Earth's crust. The Earth's crust is made up of several large pieces known as tectonic plates. These plates don't sit still, they're constantly moving, albeit at a glacial pace. In fact, these plates move at about the same rate as your fingernails grow. When these tectonic plates collide, slide past each other, or pull apart, this movement can cause an earthquake. The energy from this movement is released in the form of seismic waves that travel through the Earth. Now imagine throwing a stone into a pond. The energy from the stone hitting the water causes ripples to spread out across the surface of the pond. The same thing happens during an earthquake. The seismic waves generated by the movement of the tectonic plates spread out from the earthquake's epicenter, just like the ripples on the pond. These seismic waves come in different types, each with its own distinct characteristics. But what they all have in common is that they carry the energy from the earthquake's epicenter through the Earth. And when these waves reach the surface, that's when we feel the ground shake. So, when you're sitting at home and suddenly feel the floor beneath you start to tremble, that's the energy from these seismic waves passing through the ground beneath your feet. The shaking can range from barely noticeable to strong enough to knock buildings down, depending on the size of the earthquake. And while earthquakes can indeed be powerful and destructive, they also serve as a reminder of the dynamic planet we live on. They're a testament to the incredible forces at work beneath our feet, shaping and reshaping the Earth's crust. Therefore, the quaking Earth beneath us during an earthquake is a result of the movements happening deep within the Earth's crust. So, what have we learned about our home planet and the tremors that occasionally shake it? In our exploration, we've discovered that Earth, like an onion, is composed of various layers. The crust, mantle, outer core, and inner core each play their respective roles in making our planet the vibrant, life-sustaining sphere it is. We've also understood that these layers aren't static, they're constantly moving, albeit at a pace slower than a snail's. This movement of Earth's layers is what gives birth to earthquakes. These tremors are a result of the energy released from the shifting of the Earth's plates. This energy travels in waves, creating the shaking or quaking we feel on the surface. Knowing this, we can appreciate the complexity of our planet and the forces at work beneath our feet. Understanding the Earth's structure and the causes of earthquakes not only quenches our curiosity, but also aids in predicting and preparing for these natural disasters.